Hi, welcome to the presentation. My name is Raj Bhalwankar, and together with Dr. Jan Treur, we wrote this paper, If Only I Would Have Done That, a controlled adaptive network model for learning by counterfactual thinking at the Social AI Group, Vrije University, Amsterdam. So this is the table of contents. I'll start with the introduction and then I will move on. Counterfactual thinking is the process of deconstructing the current reality to imagine new ones, and I think most of us can relate especially when something happens that is not according to the plan, or something unpleasant happens, or something very unexpected. We tend to think about what we could have done differently, such as also like the ability to think and infer how a current situation could have turned differently, given a set of alternative actions. And often these alternative actions are based on like some nearness factor, which talks about the relevant things uh, to the current situation. Uh, and in one of the papers, counterfactual thinking was also related to mental models, of how mental models of alternative possibilities in form of mental simulations are the basis for counterfactuals. To talk about the process of counterfactuals itself, the counterfactual thinking process, it starts with a goal failure or something that happens that is unpleasant or unexpected. And it leads to like the activation where the person actually first simulates what really happened, and also based on this it triggers the activation of like a lot of prior memories, not all of them, but the ones which are very relevant based on a nearness factor. And this leads to like the next step in the process of inferencing. So the person simulates how different actions or different decisions could have generated different future states. And based on this, the person re-evaluates the current state, and this leads to updating the prior beliefs. And it also helps then like in emotion and behavior regulation, and like it leads to learning. uh, yes. The network modeling approach has like four attributes. First is like the connections, which talks about like the state values and the connections from one node to other. Also aggregation, it talks about how the impact of multiple connections at one node is aggregated. And also there's the notion of timing, which talks about how the speed at which like the value of the state changes due to the multiple incoming connections. Talking more about the network characteristics, they are defined in the role matrices, and they define the network structure. And this leads to the difference equations for the dynamics of the state within the network. For example, this talks about the weight between x and y, the speed factor, the aggregation, and the of course like the aggregated impact. And of course, like the equations are hidden in the software environment, which are specified in the role matrix format. Uh, Talking about how a network can model itself, network characteristics and network states are two distinct concepts for a network. And self-modeling is a way to relate these concepts to each other in an interesting and useful way. As a self model it's useful in making the implicit network characteristics, for example, connection weights or excitability thresholds, explicit by adding states to the network representing these characteristics. So as you can see, like there are different possibilities, like a self model for connectivity, a self model for aggregation and timing, and this can be represented by the connection weight, the combination function parameter, and the speed factor. Moving on. Uh, from the library, we use like the advanced logistic sum combination function and the step mod for building our model. So we just generated like a very real life scenario which many students especially can relate. So Jimmy believes he can do an internship and study at the same time, which happens quite a lot at I think a master's level. But he fails an exam, which it's like a goal failure, which of course creates a very unpleasant situation. This entire situation, it evokes a mental simulation of like the entire event, and maybe like some relevant memories or some similar memories to this. And this activation spreads throughout like his mind, and he thinks about like, yeah, similar situations and only focuses on the most relevant memories and not all of them. uh, and yeah, based on this, the process of inferencing starts, where he mentally simulates what I could have done differently, and maybe I could have taken up tuitions, or maybe I could have managed my study time better. I could have attended special like tuitions, and he thinks which are very relevant of all these things which I could have done, which are the most relevant, and based on these he makes like inferences and evaluations on them. And once like the relevant counterfactuals are inferred, he like the person incorporates them in the present situation. So probably the Jimmy would he would yeah, probably join some tuitions the next time, or he would probably focus more on his studies and or manage his time better with the internship and study. Or maybe he doesn't do internship at all, he just focus on the study. So this affects his behavior and his emotions, and this also leads to learning. So it also leads to like belief change, that probably he thinks that, yeah, I can do the both, but I also need to manage, or maybe I can't do the both. Talking about the conceptual representation of our model, the pink plane here, it refers to the base network of the model. The different color outlines parts are not part of the model, but uh, it's just to make a clear distinction between like the current state, which is in the red section, followed by uh, uh, the orange section, which represents the counterfactuals, and the green one, which reflects the future states. The blue plane above the pink plane, it's the first order self-model states, and the purple one is like the second order self-model states. Uh, as you can see in the red section, the current yeah, situation leads to like an unpleasant feeling, which we talked about in our scenario, the FS1, which leads to like evaluation through ES1, and like eventual separation by the WS1 of the current belief, which is I can study and work at the same time. Uh, and then this is like reevaluated, and this also leads to like the updating of beliefs. Here the update of beliefs is modeled by the EA stage and the WBA stage in the first order self model, and the NS stage are just to focus on the counterfactuals, which have small like deviations from the reality. So it chooses the best among them based on like the nearness factor. Like the choices make use of the ES stage, for example, ES from like ES2 to ES4, which have links from the second order self-model stage, and yeah, they are based on like the persistent evaluation states, and learning takes place. The belief weight representation, yeah, it's just updated, and yeah, it's the model chooses the best one. Talking about the results, you see three pictures here. They are part of the same simulation. Just to have make a clear distinctions, we have made these three different pictures. But the present situation, it of course, like the FS1, it's triggered because of the unpleasant situation, and this leads to like the evaluation state ES1, and YWS1, the initial belief state BS1 is suppressed, which you can see in the graphs here, and and only the BS5 and the stage that follow it go up, representing that an appropriate counterfactual was chosen based on the outcome of the first stage, which you can see in the future stage graph. In the model, the NS stage again are set in such a way that only one of the future stage, if you can remember in the green outline of the base network, goes for a value 1. So a typical pattern is that first the initial context state and the belief state trigger a chain of events leading to activation of ES1. This leads to activation of different counterfactuals based on their nearness and to the evaluation Y states ES2 to ES4. And the evaluation states ES2 to ES4 use their links to the CS3 states, which control the base level BS5 to BS7 states through the WBS5 to WBS states in the order to make better future choices than in the past. To verify whether the implemented network model behaves as expected from its conceptual specification, we analyzed a number of stationary points in the simulation, and the results were quite good. You can see here. To summarize, we build a very realistic simulation scenario using like various theories from neuroscience and psychology. And this model which we created, it captures the process of counterfactual thinking, which of course includes the notions of dynamics, learning, and control involved, which is illustrated in the scenario. And The parameter tuning experiments we used also showed like the root mean square error less than like 0.08, and the maximum deviation less equal to like 0.001. The present study importantly contributes to theory building in understanding the process of counterfactual thinking from a human-like modeling perspective. This it is also very useful for building AI applications. For example, like the notion of counterfactual thinking has been used in reinforcement learning to have better predictions for the agent. Further research detailing the selection and evaluation process of the counterfactuals can model a more accurate human-like process, which can be useful for the models. Thank you for listening.